All right, let's look at example 5. Now this one is tricky. We gotta just be very careful and take our time because we have a few steps that we have to do. So first thing to always remember is we're trying to isolate the absolute value. So we want to get just absolute value of -2 plus x by itself first. Okay, then we break it into the two different cases. Okay. Also, one thing to note, okay, don't write this down. Something that's very often tempting to do is distribute this -2. Okay, do not do that. The absolute value bars are treated like parentheses when it comes to like your order of operations. As far as like a grouping symbol, you do what's inside the absolute value first. But when you're solving and trying to get the absolute value by itself, and also when you're simplifying, it's not parentheses where you can distribute, okay? So keep that in mind. So think of this just as one entire quantity that we want to get by itself, and it's being multiplied out front by a 2. Okay, so we're going to be using our inverse operations. All right, so we're not distributing. There's also no like terms, okay? It may look like we can do -7 minus 2, but again, we can't do that. Those are not like terms because the -2 is being multiplied by the absolute value. So those are attached to each other. So what we want to do is we want to first think about adding or subtracting any constants. So don't worry about the -19 on the left, right? We're just looking, or I'm sorry, on the right. We're looking at the left. We want to get rid of this -7 so we can add 7 to both sides. Okay. Bring down the -2, absolute value, -2 plus x, absolute value equals, and then -19 plus 7 is -12. Okay. Then what we're going to do next is divide by -2 because the operation between the absolute value and that -2 up top is multiplication. So to undo multiplication, we divide. So that isolated the absolute value on the left. And then on the right, we end up with 6. Okay? So again, we're always trying to think about isolating this absolute value. So just get this all by itself. So we get rid of the -7 and then get rid of that -2. All right, now we can break it into the two cases. So our first case, we can drop the absolute value bars and set equal to +6. Second case, drop the absolute value bars, set equal to a -6. Okay, so this is our first case. This is our second case. And then we're solving for x, so we're going to add 2 to both sides. So x equals 8 on the first one. Add 2 to both sides over here. X equals -4. Okay, and then to check our answers, go all the way back to the beginning. Okay, go back to the original problem. And let's first plug in 8. So -7 minus 2, absolute value, -2 plus 8, it's -19. So now order of operations, do inside the absolute value bar first. So that's 6. Okay, then figure out, okay, what is the absolute value of 6? Well, it's +6. This is multiplication here. Okay, -2 times the absolute value of 6. Okay, and then the multiplication comes next. So -7, -2 times -6, -12. -7 minus 12 is -19. So x equals 8 checks out. And then now let's check -4. So again, back to the original problem. We're going to plug in -4 for x. Okay, you can do plus and negative, or I just like to write a subtraction. And then simplify your absolute value next. So inside -2 minus 4 is -6. Absolute value of -6 is +6. And then notice it's going to come out to be the same as right there. Okay, so multiply the -2 times -6, so that's -12. -7 minus 12 is -19. So that one also checks out. Okay. So it's just very important that you take it step by step. Okay. And don't worry about what's inside the absolute value until you break it into the two cases. Okay. So you're just applying the same concepts we've been doing to get that by itself. Then you break it apart into the two. Okay. There's two special cases that we want to consider. The first one is if the absolute value equals 0, then there's only one solution. Okay, and you'll see why in a second here in example 6. And then the second special case is if the absolute value is equal to a negative number, then there's no solution. So you're going to see that here in example 7. So let's look at example 6. Okay. So again, thinking what we want to do first, we want to isolate the absolute value. So we want to get the absolute value of x plus 3 by itself. So we just have to get rid of this plus 5. So we're going to subtract 5 from the left, subtract 5 from the right. But then we get absolute value x plus 3 equals 0. Now if you try to split it up into the two cases, you would kind of be looking at, all right, positive 0 and then a negative 0? Well, there's no such thing. So you just have the one case where you drop the absolute value bars and just set equal to 0. So you're really just solving the equation x plus 3 equals 0. Oops. And then subtract 3 from both sides. So you get x equals -3. And to check, so go back to the original, plug in -3 for x. You'll see in the absolute value, -3 plus 3 is 0. The absolute value of 0 is just 0, so you get 5 equals 5. Okay? So if you get absolute value equals 0, so if on the right-hand side here, you see a 0, you have one solution. You just have the one case to consider because there's no such thing as positive 0 or negative 0. So there's no two numbers to split it up into. All right. Now example 7. So we're going to see what it looks like when you have no solution. So we want to isolate the absolute value. So we want to get x plus 3, that absolute value of x plus 3 by itself. So we have this plus 10 to get rid of. So we're going to subtract 10 from both sides. So we get 5 minus 10 equals -5 equals absolute value x plus 3. Now you might be tempted to break it up into two cases and set one equal to -5, one equal to +5. And you could go and get two answers. But if you check it, it actually won't work. But to save yourself that time, think about this. Remember from the very beginning, we said absolute value means the distance from 0. So what this is saying is the distance from 0 of whatever x plus 3 is -5. Okay, we can't have negative distance. Right? There's no such thing as a distance of -5. So, no solution. There's no number that will give you a distance of -5. Okay? So if you see a negative on the either left or right side, whichever side your absolute value is not on, if you see a negative, it's no solution. All right. Let's look at a word problem now. So it says the Sydney Harbor Bridge is 134 meters tall. The height of the bridge can rise or fall by 0.18 meters because of changes in temperature. Okay, Write and solve an absolute value equation to find the minimum and maximum heights of the bridge. Now you probably can just figure this out, right? Here's the height, 134. We can either add 0.18 or subtract 0.18, right? It can rise or fall by 0.18 meters. But let's see what that looks like as an absolute value equation. So if we let B be the bridge height, right, considering the plus or the minus, then if we think about, okay, so the bridge height, if we subtract the 134 feet, then that is going to be equal to, and take the absolute value, so whatever that positive difference is, if we find that positive difference, it's going to be 0.18, okay? Because the positive difference could be 0.18 up, right? So it could be 0.18 meters taller or 0.18 meters shorter. So the difference in distance between the height of the bridge, right? So it's 134 meters tall. So if we add a 0.18 or subtract 0.18, that difference is 0.18. So here's our absolute value equation. So if we break it down into the two cases, so B minus 134 equals positive 0.18, or B minus 134 equals negative 0.18. So if we add 134 to both sides, so we get one case here, one option is it could be 134.18 meters tall, right? So that's adding, rising 0.18 meters. And then in case 2, if we add 134, we get 133.82 meters. So that's the minimum height. 134 is the maximum height. Okay, so this one would show you rising the 0.18 meters. This one would be if it falls 0.18 meters. Okay, so that wraps it up for absolute value. I know that was kind of a lot. So really take your time, go back through, look at some examples again, and then come to class next time with questions. We're going to review all this, but we will have a short quiz at the end after we review. So try your homework and come to class ready with some questions next class.